All right, welcome to section 6.3, binomial radical expressions. Example 1, we're going to add these two binomials together. So binomials have two terms. So here's the first term, 14a square root of 7b plus 5a square root of 7b. So this is kind of an extreme example. Basically, this is a common thread between the two terms. So since these are the same size pieces, we can go ahead and add the two things together by adding the coefficients, which is the numbers in front. So this is no different than saying what is 5x plus 14x. So those are the same. I can add them together because they're like terms. So I get 19x. Now if I had 5x plus 14y, I couldn't add those together because they're different. But this is the same like termness. So I can say, hey, I have 14 things and I have 5 things. Now they're the same size things. They're a little weird, but I can add them together. So I get 19a square root of 7b. Example 2, I'm also going to add these together. So I'm going to add as well. Now subtraction can be done with this, but I'm going to do addition for my examples. Square root of 28 plus square root of 175 plus the square root of 63. Can I add these together? No, I cannot add these together because they're different size pieces. I need to break them up into the same size pieces so I can add them together, so they're like terms. So I need to make them all kind of look the same. So how am I going to do that? I'm going to do square root plus square root plus square root. I'm going to go to simplest radical form. By simplest radical form, we take out the perfect square that lives inside of 28. So what perfect square lives inside of 28? Well, it doesn't take too long to figure out that it'd be 4. 4 times 7. So 7 is the factor that you can't take the square root of, and 4 is the factor that you can. Then we're going to go to 175. So what's the perfect square that lives inside of 175? How about 25? 25 is a perfect square. It divides in there in 7 times. And then it doesn't take too long to figure out that this would be 9 times 7. And it's like, oh, look, now I have like terms because all of them have the square root of 7 in them. So they're now the same size pieces. I can add them together. So I have 4 of this piece, which is the square root of 7. And I have, oh, not 4. Whoops. It's the square root of 4, which is 2. So I have 2 of them, and I have 5 of them. By them, I mean the square roots of 7. And then 3 more. So I have 2 things that are the size of the square root of 7, 5 things that are the size of the square root of 7, and 3 more things that are the size of the square root of 7. Since these are all like terms, I can add together the coefficients in the front. Remember, the number in front is called the coefficient. So that'd be 7, and then 3 more would be 10. So it's 10 radical 7. So this statement up here of adding these 3 radicals together is the same thing as 10 radical 7. So the name of this section is binomial radical expressions. And I added two things together. This is a binomial, has 2 terms, but I added it together to make 1 term because they had like terms. Here I had actually a trinomial because there was 3 things. Could I add that together? No, not until I made them all have the same size piece to link them together. All right, example 3 is going to be multiply. So example 3, we're going to multiply 2 binomials together. And so my example is 5 plus 3 radical 2, and it's going to be times by 5 minus 3 radical 2. All right, so we're going to do this with the old-fashioned FOIL. First, outside, inside, last. So 5 times 5 is 25. 5 times the 3 in the front. Now I can't multiply the 2 because that's not really a 2, it's a square root of 2. I just multiply the number times the number. The radical follows along. So 5 times 3, it's actually negative, so it's minus 15 radical 2. This times this is 5 times the 3 again, 15 radical 2. And then this times this. When you multiply, you can only multiply things that have the same index, right? So I can multiply the 3 times the 3, and I can multiply the square root of 2 times the square root of 2. You got to match up the indices. So 3 times 3, of course, is 9, and there's a negative there, so it's negative 9, and then that times that would be square root of 4. These are like terms. They definitely cancel each other out because I get 15 things minus 15 things. 25 drops down. This would be 9, and that would be 2. So it would be 2 times 9. See, that's a 2 because it's the square root of 4 is 2. Times the 9 is 18. Then you subtract, and you get 7. 25 minus 18, 7. So this times this all simplifies down to 7. Now I'm going to use this technique of multiplying two binomials together with one binomial being positive and one being negative, and everything else is going to be exactly the same between the two, to rationalize the denominator. So example 4 is to rationalize the denominator. So that's going to mean we're going to get rid of the square root on the bottom of the fraction. So there's a square root down here in the denominator, and I'm going to get rid of it. How am I going to get rid of it? Well, I'm going to multiply by 1, a fancy 1, but it's going to be 1 nonetheless, and that 1 is going to look kind of like the opposite from here, like how this is 5 and 5, and this is 3 radical 2 and 3 radical 2, plus and minus. So what I'm going to do is I'm going to pick a fraction out here. The fraction is going to be equivalent to 1, and it's going to be 6 minus radical 3. So that 6 matches 6, radical 3 matches radical 3, 1's plus, 1's minus. And that will get rid of the square root because the middle terms cancel out. And the top is 6 minus radical 3. So the same thing divided by the same thing is 1. So I'm multiplying by fancy 1, basically. Parentheses around this. Let's put parentheses around that. That way it looks more like FOIL. Okay, the top is not FOIL. The top is just straight up distributing. So I'm going to 11 times 6 is 66. 11 times this would be minus 11 radical 3. And then this times this would be 36. This times this is minus 6 radical 3. This times this is plus 6 radical 3. And this times this is minus square root of 9. So I can multiply those together because they're the same index. So I just multiply the 3 times the 3 underneath. 6 times the radical 3 thing is 6 radical 3, and again 6 times the radical 3 thing is 6 radical 3. And then follow the pluses and minuses. The middle part cancels out, which is what I wanted it to do. That way there's no square root anymore. That's not really a square root anymore because that's going to be 3. So, and then minus 3 because the minus. So it's 36 minus 3 is 33 on the bottom. And then on the top is 66 minus 11 radical 3. Now, that's a pretty good answer. I've achieved the goal of rationalizing the denominator. However, I noticed that, especially if like this kind of looks like a quadratic formula type situation where you have a number and then you have something and then there's the radical and all that. So these 3 parts there have the common factor. A lot of times it's a common factor of 2 if they're all even, or a common factor of 5 if they all end in 0 or 5 or whatever. But here's the common factor is 11. So I can divide each one of these green things by 11. Divide by 11, 6. Divide by 11, 1. And divide by 11 would be 3. So that's actually the simplest. So what we did is we added together like terms. Example 2, we created like terms so that we can't add or subtract. Adding and subtracting basically do the same thing. We multiplied 2 things together by FOIL, 2 binomial radical expressions, and then we used that technique of multiplying to rationalize the denominator.